Okay. There is a piece, you maybe can't see it very clearly, but we can have a look when we go out to the unit. There's a piece here which is a circuit breaker. Okay, so like it's a big fuse on the supply side. Yeah, we've got the circuit breaker. So even if we had every sensor connected on the outside of the box, as many as it could handle, right? The maximum current, the maximum amount of electricity that would be drawn through the system should be about 3.5 amps. All right. Circuit breaker here is a 5 amp circuit breaker. So if the box draws more electricity than 5 amps, this will go pop and it'll just shut down the box, because if it's drawing more than 5 amps, there must be some problem, some short circuit, something like that, and we don't want it to spark and burst into flames, and that's a problem. Okay, so we've got some security, or we've got some safety measures in there to start with. Okay, on the supply side. Right, so this part of the box, this is just power supplies, changing the voltages. The middle part, this part with all the wires and things, this is just about distributing those different voltages to the different parts that we need. Right, so the 12 volts come in, and then 24, 12 and 5 come out, and they get distributed. There's different sections. Okay, you can't quite see it from the labels here, but these labels say 24 volts, these labels say 12 volts, and then there'll be some that say 5 volts. So we've basically got a strip, or a terminal strip, okay, that we can then connect wires to here to deliver the power elsewhere. Right. Now there are some orange wires, all right, which kind of go from this part over to this bit here. Wherever you see the orange wires, this is all about what we call the diagnostics. So the troubleshooting that I mentioned. In the software, the latest version that you guys have here, okay, we can look at the computer and we can find out what the signal coming from circulating pressure is. We can actually see the milliamp signal. We don't have to get an electrical meter anymore and get inside the box and try to measure it. If we're troubleshooting, we can actually see it from the computer, and that's because of this section with the orange wires. This is the diagnostic section. So it's actually reading the signals that are coming into the box and displaying them for us out here. Okay. Okay, so the power's coming in, we're getting split into different voltages, and then it's getting distributed along this strip. Okay. You can see the wires underneath here. All of these wires are all going to the back of the connectors on the side of the box. So we're supplying the different voltages out to the box, out to the sensors. And one of the wires, one of the 5 volt wires, okay, it's coming down here and it's running the rest of the acquisition system. Okay, so power conversion, power distribution, and then this part is the bit that does the work, if you like. Okay, so we're going to send the power out to our sensors, and the sensors are going to send signals back into the box, all right, through the same connectors, and those signals are going to come in the white wires down the side of the box and into the relevant, what we call a module. Okay, you might call them cards, data cards, or something like that. Okay, these just slot in. This is like a circuit board. They just slot onto the circuit board. But we need a different type of module to read different types of signals. So different types of sensors, right? Now predominantly we only use 3 types of sensors in our units, standard units, right? We've got analog or pressure sensors, yeah. We've got digital, or the rate and volume sensors, and then we've got the special one, which is the depth encoder, yeah. So it's got a special signal by itself. So in our box, we've got one module for reading the depth signals, we've got one module for reading the rates, the volumes, the pulse digital signals, and then we've got two modules for reading analog or pressure transducers. Now we can add more. You can see there's some empty slots, so we could add more stuff in there. We could have more rates and volumes on the digital side. On the analog side, a pressure transducer is just one type of analog sensor. You could also have temperature, or you could have density. There's different types of analog. It's described as analog because the signal is always on, and it just varies with whatever you're measuring. So if you imagine the pressure transducer, okay, a pressure transducer needs 24 volts, so it's supplied from this first area, 24 volts goes out to the sensor, and then even if there's no pressure on the sensor, it returns a signal, 4 milliamps, it returns a signal back to the box. So even if there's no pressure, we're reading a signal here. Whereas the digital ones, if the pump stopped, there's no signals coming back to the box. Okay, so that term analog means always on. So it should always be reading something. And that kind of helps us a little bit with the troubleshooting. So you've had a look at that kind of wiring diagram. This showed us on the power strips, it actually told us that this one, if I look at this one, the second one in, that wire is the wire for A1 pin A. And now A1, if I look at the other drawing for the connectors on the side of the box, and I find A1, where's A1? A1, analog 1, A1 is wellhead pressure. So I know exactly which wire is providing the power for the wellhead pressure sensor. Yeah? So they're all connected, these drawings. Right? And we can figure out what wires what just by having a quick look and reading the things. Okay, so let me pass this.